Okay, in the last video, we just kind of set up the problem. And so what we decided was we're going to try a regression model. We're going to use the same two files that we used before, and we're going to read in the data. We got to do some installing of things. So I've already installed this, but this is the code to install stats model. So it's conda install, and then dash C conda dash forge stats models, right? And I just went out and found that. We also want to install another package called Patsy. And you're going to do that not through conda, but through a pip installation. All right, and then we want to import stats models dot API as SM, stats models SM, import pandas as PD. We want to import numpy as NP. We want to import date time, and then from Patsy, date time, and then from Patsy, we want to import D matrices. Okay, these are just some in my research. I thought these were things I thought were going to be helpful. All right, so let's read in our data. Df equals pd read underscore csv, and we want to read in sales final 6302021.csv, and then we want def sales date, and we want that to equal pd to date time, and that is df sales date. And then we want to read in the purchases invoice file, and we want that to be pd.read underscore csv, and we want invoice purchases 6302021.csv, and then we want to take our invoice date and we want to convert that to date time. That in quotation marks. Great. Okay. Beautiful. I think I got all that. So I'm just going to make sure, I've already got these things installed, so I'm not going to run that, but I am going to make sure all of these are imported correctly. NP, not MP. And I want to read in my data. So while that's all reading, we'll go to the kind of the next description of what we're going to be doing here. So in the correlation example, we used sales dollars. Let's switch out sales dollars and use sales quantity. All right, because we're talking about bottles, so maybe dollars aren't related, because if I have lots of bottles that are very expensive, but it didn't cost me that much to ship them, so maybe bottles might be a better representation, but whatever. We're just, again, we're going and trying some stuff, right? We're going to continue to use weeks. So we're going to boil this frame of reference down to weeks. Okay, and so let's put in that code. And remember, we're using the date time function here. So what we want to do is df, we're going to create a new variable called week, and that's going to be equal to df sales date, and we want to switch that to dot dt dot week. And then I want to do the same thing with a new variable in the invoice file called week, and we want to df inv, in this case it is the invoice date, and we want dt dot week. All right, and then we're going to create two series. So I'm going to run this. I'll put this as a cell. I'm going to run that cell. Okay, so I should have my variables loading in there as it's going through the process. So we're going to put in, we're going to create two series grouped by week number. One will have the sum of sales quantity by week, and the other the sum of freight by week. Right? And so I've created I'm going to create these two series, and we're going to use these in the model. Okay, so simple grouped S is going to equal df group by, and we're going to group in this case by week. Oops, I got the wrong thing in there. Group by, there we go. And we're going to group by week, and grouped F, we're going to df inv group by, and again we're going to group by week. All right, then we do df summary S is equal to grouped S, and here we're going to group sales quantity, and we're going to aggregate, and we're going to use np.sum and df summary F. We use grouped F, and here we're going to group freight, and the aggregation is the same, np.sum. Okay, so we're going to run that, and I'll just run this all as another cell. Run that cell. Okay, and now I got my two series of 53. Great. All right, let's keep going. So this may be a little bit of a longer video. That's okay. Now we're going to create the model. In the next video, what we'll do is we'll take a look at the model outcome. Next, we create the model. Here, we believe the dependent variable is freight, and the independent variable is sales quantity. Okay? So when I can model that, I can write out the model that freight is equal to some coefficient, we'll call it M, times sales quantity plus some just some unknown amount plus some intercept, right? And you've seen this before. This is the same as y equals mx plus b, or whatever, ax plus b, however you have learned simple regression. Okay, so it's a very, very simple model that we're putting in place here. All right, so let's do it, and then we'll evaluate it. So we're going to create the model, and that's going to be SM, which is that stats model that we imported, sm.ols, so ordinary least squares, and it's going to be the y variable first and then the x variable. So df summary f and df summary s. All right, we're going to define this as, give me the res. We're going to define it as res, and I want to know what is the model fit. So what is the fit of the model? So here's mod, and I want to know what the fit of that model is. And then I want to print, and I want res, right? So there's my model fit, and I want them to print the summary, right? So I want to print all of that out. All right, so we've got our group, we've got our model, and now let's run this. I'm going to run this as its own cell, and then in the next video we'll do some interpretation. But this is it, right? This is running an OLS, an ordinary least squares. This is the Y, freight. This is the X, sales quantity, and I'm saving that as model. And then I'm going to get my results, RES, and I want to know what is the model fit, and then I want to print out the summary of the results. So that's what this little code, these three lines are doing here. So we run that, and we get this nice output. We're going to go through this output in the next video and figure out what it all means.